Hey everyone, welcome to the second half of the AltViz 2022 workshop. This section we're going to be looking at a lot of interesting topics, generally themed under the work of the Greek god Hermes, or algorithmic works, covering playful tricks, visualizations, and unexpected places. So it's going to be a really fun time, and I want to remind everyone that we want to ask questions through Slido. The Slido link can be found in the Discord for this room, which is OK7. So, Sarah, you want to come up? Our first talk is by Sarah Bartolomeo, who's a PhD student at Northeastern, and it's on the worst graph layout algorithm ever.
Is it supposed to be your talk first? There's a few minutes of something that you say.
That was it.
Okay. Okay, I'm ready. I'm ready anyways. Cool. Let's try it again. It worked a minute ago. Grab it. It was working perfectly a second ago.
You never know with adapters. Oh, different USB-C port. Nothing.
It could be their HDMI though.
Could be their HDMI. That's the next thing to check.
Incredible. We tried.
We're trying. How many computer scientists does it take to resolve a tech issue?
I can't believe this. I can try and restart the computer, or I can send the presentation to somebody.
What's the next thing to do?
Try a different computer to see if it is.
Oh,
Okay.
yes.
Now we try to take three different computers.
We got kicked or something?
Maybe the resolution and the frame rate. We go to the Apple menu in the top left, and the system settings, then display.
The easiest one would be to send the presentation to somebody
What
else.
did it?
It's the system settings, and then the black button. Scaled. Just underneath. Switching it. If you switch scaled, and there's a checkbox underneath the drop-down menu. Another drop-down, a radio box underneath.
Oh, okay.
And then 1080. And if you just switch, try to
No, the just 1080.
When I
Right now on the hertz.
Oh, wait. Oh,
There we go.
yeah.
yeah, I would just
TV, the hardest problem in tech.
Can you hear me? Yeah, okay. Hi everyone. Today I'm going to talk about the worst graph layout algorithm ever. So let me first introduce you quickly to what's a graph layout algorithm. Graph layout algorithms are needed to assign positions and nodes to nodes and edges in a graph so we understand what's going on in a graph. Okay, so we have an idea about the structure, the size, how nodes are related to each other. We need graph layout algorithms to position these nodes in space so we can see what's going on in a graph. So usually we want to do this by respecting some readability criteria. The most important one is to not make the edges cross. And that's the holy grail of graph drawing. And I just named graph drawing. Graph drawing is the name of the field that cares about these things. And it's a field full of math people that really like to invest all their time on problems that have no real connection to reality. And I say this while considering myself a part of the graph drawing community. So last year, I made an optimal layout algorithm, which is basically an algorithm that gives you the perfect result in terms of number of crossings. Gets the least amount of crossings in the drawing of a graph, the least possible amount of crossings in the drawing of a graph. You can't do better than that. And it's really cool, and it's made with this slightly complicated thing called linear programming. So now when people get to know about my project, they tell me, oh, wow, that's brilliant, that's genius, you must be brilliant at math. And I'm definitely not, but I just let people think that. So what we do with this method is we write constraints like this, and we have an objective function, and in the space of feasible solutions described by these constraints, we can look for a combination of variables that maximizes or minimizes our objective function. And if you write these constraints in a clever way, this can give you the correct placement of the nodes to get the minimum amount of crossings. And in our case, the objective function is going to be to minimize the total sum of crossings in the final drawing. Don't worry, I'm going to keep the whole presentation light. I'm not going to go into any more detail than this. Just keep in mind the objective function. Obviously, there's a number of trade-offs which maybe should be mentioned. It's not perfect. My method is not perfect at all, but we'll completely fly over the issues involved in my great algorithm as they are not the point of the talk. The point of the talk is, my algorithm optimizes for the number of crossings and for edge length, which are the things that most negatively affect the readability of a graph. But in the true spirit of graph drawing, where we care about absolutely useless things that do not matter at all in reality, we might wonder, what if instead we want to get the worst possible result instead of the best possible result? And the solution is right in front of us. Since linear programming works with an objective function, we just reverse the objective function. So instead of saying we want the minimum total sum of crossings, we say that we want the maximum total sum of crossings. And this gives us the provably worst graph drawing possible. So here you can see one result. We go from just 4 crossings to 33. Beautiful. Let me show you another example. A while ago, the famous comic book artist, you might know him, probably you do, since you are scientists, XKCD, published a visualization of storylines in movies, and everyone in graph drawing went crazy over this. We absolutely had to find an algorithm to make these movie storylines computationally instead of manually. So this is the storylines for Star Wars. It's just a section because it didn't fit in the entire slide, but you get the idea. Basically, time goes on the x-axis. Every line is a character, and characters that appear together in a scene have their lines represented together, like this. So this is a graph drawing problem. We want to draw these lines so that some characters appear together at some points, but there's not too many intersections where they are not needed. And here's my version. The one on top is optimally good, and the one on the bottom is optimally bad. So we go from 37 crossings to 5,178% increase, which is not bad. So you might ask yourself, why did we do this? I previously mentioned we don't really care about the applicability of our results, but we went to great lengths and even figured out a number of scenarios in which the worst possible layout algorithm can be useful. For instance, you might be a researcher that has developed another layout algorithm, and you want to prove that your layout algorithm is really good, so you compare it against something else. Well, if you pick my terrible layout algorithm as a baseline for the comparison, you're guaranteed for your own algorithm to look awesome. Second use case is an application of some graph layout algorithms is making the layout for electronic circuits, so you can position things in a way that makes sense in electronic circuits. Well, in this case, the messier we make the layout for a circuit, the more difficult it is to understand what's going on. So this might be an application, obfuscating circuits, like you do with code, right? You obfuscate the code by making it messy. Another use case could be designing highway interchanges, since they like to get really messy and confusing. And now we get to other metrics to optimize, to absolutely destroy the readability of a graph. This is my future work section. This is not implemented yet. So, for instance, one could maximize edge length, but we would have to keep in mind that the maximum edge length on an infinite plane is infinite. So we would have to think about something for that. Then we could perhaps maximize edge bendiness, the amount of curves in the edges, right? Here I had some fun trying to imagine how maximized edge bendiness would look like. And what about maximizing rocket cheapness? How much does this graph resemble a rocket? Why not? So that's it. Thank you for listening. We also have supplemental material, and we have a demo online in which you can play with your own graph to ruin it as much as possible. Thank you.
Wow, thanks for that wonderful talk. Well, we're still waiting on some questions from Slido, but one that was top of mind for me is, so this work obviously exists both in the Viz community and the graph drawing community. What do graph drawing people have to say about this?
So I actually, after I published the preprint of this paper, this one that has submitted to AltViz, it showed up on Google Scholar, and it generated some traction. So some people saw it, and I got interesting reaction to it. For example, this person here wrote to me somewhat angrily, taking this issue extremely seriously, and adding a bunch of people too in CC, including professors, with an email complete with LaTeX formulas in the email. And he completely missed the point of the paper, which was just satirical, which was just a joke. I had to respond, yeah, look, it's a joke paper, you know, it wasn't serious. Yeah, so that was one of the reactions.
I think, to me, that seems like a alt success.
Yeah, I was very happy, very excited. We had an exchange.
Yeah.
Sorry.
Something else I wondered is, in your paper you talk about unicycle problems. I wonder if you could explain what those are, and if you see any other ones other than the what you...
What kind of problems?
Unicycle?
Unicycle.
Yes.
Do I talk about unicycle problems?
Yes. Well, some alt chaos. All right. I had a more minor technical question. Couldn't you trivially make this work by making all the points overlap?
That was one of the constraints. That would be too easy. Not fun enough.
That's fair.
Yeah, but there's definitely other ways in which you can destroy the readability of a graph. We can compete. I'm open to any challenge. You can ruin a graph more than mine. I challenge you to beat how bad mine is.
You heard it here first. She'll make whatever graph you have worse. Well, we have a question from online, which asks, do you envision extending this work into 3D space? And if so, how?
It's a bit difficult to talk about crossings in 3D space, right? Because you have a definite understanding of what's a crossing in 2D space, but it's not as easy to make edges cross in 3D space. So there's not exactly the same definition. You can reason on projections, maybe, but that's still transforming a graph in 2D. So readability follows different rules for 3D space. So yeah, definitely, this could be something to think about, but none of this applies to 3D space.
That makes sense. Oh, and we have one more. What type of visualization would you like to ruin next?
Interesting question. There's many possibilities. We could have a challenge on how bad pie charts can get.
I would like to see that.
Yeah.
Well, great. Thank you so much. This was a lovely talk. And with that, we'll move on to our next speaker, which is Matt Lang from Massachusetts. from Matt Lang from Maastricht University, presenting his paper, This Name Can Be Automatically Generated.
I guess you don't need it, right? Oh, Sarah doesn't need her phone. You can keep it here. You can chat with her.
Yeah.
Thank you. Can you all hear me? I like how I am in the darkness, so it sounds like a voice from darkness coming to tell you about. What am I going to tell you about? Okay, so hello everyone. I will take it. I will take the mic. Hello everyone. My name is Matt, or Matěj Lang, and I'm one of the co-authors of the paper, which the title you can see on the screen. This is one of my other co-authors, so this should be a warning for all of you who want to collaborate with me, that you might end up like this. So the actual name of my paper talk is This Name Can Be Automatically Generated, which you can see here in the background running. And so we decided to take a deep dive into how the visualization community creates their paper names. And as a first thing, we created a random name generator for that. And as inspiration, we took several ones. So, for example, the Dadaist poets decided that the best way how to create poems would be to cut up newspapers into individual words and then put them in random order to create works of art. Or the well-known game Cards Against Humanity is creating semi-random, most atrocious or funny phrases, depending on in which group you are playing it. And in the last decade, we have seen a rise of neural networks that are creating the content that was never before seen, and this is also a great source of randomly generated stuff. And so, as a fun project, and we were just having fun with my coworkers, we created a generator of paper names. It works quite simply. You just put a big pile of nouns next to a smaller pile of adjectives, put in some scientific sounding words, you shake it a little, and you create a reasonably sounding paper name. Well, maybe not as reasonable, but I would say close enough. But from that, we were wondering how well does it correspond to the real papers in the wild, and how do communities, scientific communities, name their papers? And so for that, we took a look in other fields. And so, for example, the British Medical Journal has published more than one study, actually, on this issue. They, for example, took a look into culture phrases such as pushing the envelope or similar, and they looked at how often they are showing in paper names. Then they also looked into cultural references. And the example, the good, the bad, and the whatever you can smash at the end is one of the most used movie phrases or movie references. There is a Swedish group of scientists that have a long-running bet on how many Bob Dylan lyrics they can put into paper titles. So, for example, nitric oxide and inflammation, the answer is blowing in the wind, is one of them. And there have been also works on other cultural references throughout all the fields, from where we can see that the social scientists have roughly 30 times more cultural references than, for example, material science, and the computer science is sitting somewhere in between. And nobody has done anything for visualization field, per se. So I decided that I will be the first one, and so we did it. Our data analysis consists of almost 1,800 papers from the last 10 years of IEEE VIS. Those are only the full papers, so there might be more treasures in short papers and posters and so on. And I will now present what we found. So, for example, there is a rather big amount of hyphenated words in the titles. So you can see that at least 1/3 of all the paper names have at least one hyphenated word, with this being the absolute winner, the KD box, line segment-based KD tree for interactive exploration of large-scale time series data. This is amazing not only because it has 5 hyphenated words, but also one of the words has double hyphens in it, which puts it at the absolute top. The most used first word in the hyphenated ones is multi. The most second one is based, which means statistically the most used hyphenated word is multi-based. When we continue with the analysis, we looked at the colon and the position of colon in the paper names. Sorry. And the vast majority of them was found between the first and second word, which is obvious. It usually consists of the tool name that then is explained. And the tool names are very often the thing that the paper talks about. And so here are some of the examples. Here are stenomaps, shorthand for shapes, or my absolute favorite, pelvis. Atlas-based surgical planning for oncological pelvic surgery. I mean, there was a stroke of genius in coming with that one. When we looked at the cultural references, we found surprisingly little. There were only about 20 cultural references, and so here are some of the examples. We have the ever-pervasive, the good and the bad and the ugly. Then from other movies, we have Jurassic Park. And for the music scene, we have YMCA, your mesh comparison application. After I asked one of the co-authors, it's definitely a reference on a 1978 hit by Village People and not Young Men Christian Association. So it counts. And so with these examples, we decided to improve our generator, and here are some of the examples how we did it. First, we generated hyphenated words in a way that we randomly create one half, and the other one is from the list. Then we expanded the list of jargon phrases so it sounds more scientific. And then also we improved the tool name generator. So here you can see from 2 words, if they share a part of the words together, they get smooshed to create, for example, campaign or spectaculans, which is just beautiful. And in conclusion, we not only created the generator, but we also created a quiz, which I all invite you to try it. So you can take out your mobile phone, scan the QR code while I keep blabbering, talking. There are 10 answers. 5 of them are generated paper titles, 5 of them are real ones, and your task is to say which is which. Also, we found out that the visualization papers are often unremarkable. I'm sorry to say that, but it is true. We should try harder. We should make the paper names more interesting, more fun to read, because what else can we do with them? We have created the whole tool for fun, but also for inspiration, because we found out that even the most ridiculous ideas at first can expand into something extraordinary. So here is a tool that can seed your ideas and create your next big publication. And on behalf of my co-authors, I would like to thank you all for visiting, and if you have any questions.
Thanks for that wonderful talk. While we're waiting for some questions to come in on Slido, I want to know, how do you think we as a community should change in response to this? Like, should we be naming our papers differently, like, or the same? What do you think we should do?
That's a good question. I don't think I have the authority to say what we should do. What I would do personally is to think about whether the name will stick after I read it in the list of 5 other names. So I think we should try to put more. And I talk about it in the paper also. We should put more memorable words and also so the combinations in the paper titles, so they stick out more. They are not just the jargon flow from the beginning to the end.
That makes sense. And Elsie had a quite closely related question, which is, do you think that more interesting titles lead to more people reading or remembering that paper? Like, is there a benefit in being creative? Like, is it just memorability, like you say, or do you think it can like increase the visibility of a paper by having a unique name?
Oh, definitely. It can create, and I think we can see it in advertisement, and in a way we are creating an advertisement for our paper when we are naming it, and we can see that we can both do a positive and negative advertisement, and as long as it sticks out and is interesting to people and they remember it, I think it's worthwhile at least to try it.
Kind of reciprocally, what would you say to reviewers who request more professional or more boring paper titles?
Eh.
Do you think that cultural references increase citations, or do you think it's puns that are better, or where do you think the best strategy is for this?
That's also an interesting question. I was also talking about it in my paper, and I can't really remember what were the statistical results. I think that they don't really increase the citation rate, but I don't know. I think it's, regardless of citation rate, I wouldn't just go for the hard numbers. I would go for the memorability and just plain having it more interesting, rather than going for more citations because of my work.
That's fair. Well, let's thank Matt again for the really lovely talk and the great Q&A.
Thank you.
Next up, we have a online talk from Jane Adams, one of the organizers of this workshop, who is a PhD student at Northeastern. She'll be talking about Ready Player VIS, player-created strategic visualizations for video games.
We don't have her on Zoom for some reason.
Oh no.
Thank you, Andrew, for that introduction. Can everyone hear me? I just want to make sure. We've had a couple of technical difficulties. Can I just get a thumbs up in the chat? Okay, awesome. Thanks. Yeah, thank you so much for that introduction. So today I'd like to present on Ready Player Viz, player-created strategic visualizations for video games. So our question was, there's a lot of existing research out there on how game developers develop user interfaces for video game players. There's a lot of research on player behavior. But one question that we felt was an open question was, how do players themselves design visualizations for their communities? And this in part was inspired by our own experiences as video game players, looking online and going to communities like on Reddit and in different fandom wikis to gather visualizations that helped us better understand certain game mechanics or improve our play style. So for the purposes of this survey, we sourced visualizations initially from Reddit. So we went into game communities for specific games and reached out to people and basically just asked, hey, do you have any examples of visualizations that have been useful for your gameplay or as kind of an explanatory tool for giving background on a specific like in-game story? And from those surveys, we collected a bunch of visualizations. Interestingly, there was some sort of formal and informal snowball sampling where not only did we ask people, hey, who else, what other game communities should we reach out to, but in some of the communities that were particularly responsive, they pointed us to additional communities that we hadn't considered before that we should reach out to. And we collected a total of 89 visualizations in our kind of first pass of this survey. We're hoping to expand it further. But from those visualizations, we categorized by type based on the data visualization catalog. And we added them to a database, which is on our website, and the link is here. And you can see on the right the kind of representation of different game communities in our preliminary survey, with Civilization and Minecraft tied for first place, followed by The Sims, which has been around for quite a while. So we kind of categorized all of the Sims editions into one category. Stellaris, Stardew Valley, etc. So we were really interested not only in the end product, but also in the process that brought people to these visualizations. Some of them are extremely complex because the underlying game mechanics are quite complex, or because the underlying story and the number of characters involved were very dense networks. So some common themes that we found are that these were the products of community-driven design, so there was multiple iterations on a lot of these, oftentimes taking place on websites like Reddit, Twitch, different wiki fandoms. There was a lot of forum feedback, and it really was truly a community process. So this is just some pull code examples from Minecraft logic gates, of different users kind of commenting on how they felt about the visualizations. So one Redditor who has actually taught circuitry has used diagrams like this and found that students new to the subject learned better off 3D renderings of the circuit. That actually prompted another user to share some 3D renderings of circuits that they had mocked up in a 3D rendering tool. Another user commented on how the visualization was a little bit out of date with a new piston system, but agreed that it was a very handy diagram. So we can see also that some of these visualizations change as the game changes as well. And another user said, I actually find the diagram more confusing than someone telling me how to make it. And so there are also a whole bunch of YouTube videos about how to make specific kinds of mechanics in Minecraft, which uses redstone, which is very similar to electrical circuitry, and has a lot of the customizability that we have with actual circuit design. And it's pretty incredible to see what some users have created in Minecraft using these basic logic units to create full computers. Recently, even there was one Minecraft computer that was able to run a version of Minecraft within the computer that they had built in Minecraft. There was a great diversity of type in the visualizations that we found. So we've kind of categorized them that way, and you can also, when you visit the website, filter by the categorization. We did categorize some visualizations into multiple categories if they were more of like a dashboard layout with multiple visualizations kind of occurring side by side, or if we just felt that they fell into more than one category. But you can see some of those represented here. In particular, node link diagrams, the first 6 up here, A through F, on the bottom here, and then maps on the top, A through F. So yeah, node link diagrams represented 30 out of the 89 visualizations that we found. This was in part due to the content that they were representing, so recipes, timelines, and maps. And then another common type was maps just more generally, and then also tables. And we posit that the tables may be a result of a lot of gamers not necessarily having a lot of exposure to or even access to useful visualization tools. And so tables are really easy because all you need is Microsoft Excel or Google Sheet in order to create tables. But they do add a lot more kind of visual encodings to those tables by putting in iconography and things like that. Some surprising types that we particularly liked included a dasymetric dot density map, which we see in the center here. This is from a particularly large Minecraft server, which shows the locations of all of the players at a specific moment in time. We also found 3D spike maps of density, and 2 examples of state machines, which is a special kind of node link diagram. There was actually a really interesting website that had a very large collection of interactive state machines for all kinds of not only video games, but also board games. Additionally, one chord diagram showing relationships between Pokemon types created using d3.js. So for a lot of these visualizations, we weren't sure who or what visualization tools users had used to create these, but occasionally a user did post them with some background about the tools that they used, and so that was particularly interesting also. So we have our survey results up on the website as an Airtable, and the ability to filter by type or by game. You can click on them and actually go back through the link to the source. But as I mentioned, these are just the 89 visualizations that we found in our preliminary survey. And we would really love to expand this repository because we think that it could be useful not only for the players of these games, but also to the developers of these games for thinking about additions to the user interface, and finally for visualization researchers to think about oftentimes we talk about gamification of visualizations, but what about visification of games? So yes, thank you for listening, and please don't hesitate to reach out if you have suggestions for us.
Hey Jane, thank you for that awesome presentation. Do you want to turn your video on for the Q&A?
Sure.
Great. I am virtual Andrew right now, so I'm taking over so we don't have that sort of mismatch in virtual and real space. The first question that I have for you is from the audience, and where did it go? Do you plan to investigate the tasks that I'm assuming players plan to do while using these visualizations?
That is a great question, and definitely an interesting area to take this research to. One thing that we found challenging as we were doing these surveys and coding them is some of the visualizations are so deeply embedded in the game's culture and lore that if you're not a player of these games, it can be really hard to kind of make sense of what they're even talking about. For example, the game EVE Online has an incredibly complex economic system. And so for us who had never played that game before, we were doing a lot of background reading about that game in order to understand it. And so I would say that it would be no small undertaking to consider the tasks that each of these visualizations are solving, because it does require a certain amount of game community knowledge.
It's super interesting. With slightly changing topics a little bit, Elsie asks that, or I guess comments, the iteration on visualization is really interesting. Did you find that it's usually one person iterating on their design based on feedback, or is it usually several people working on it together?
Generally, the visualizations that are explanatory are the ones that are created by a single user, and it's just that one user iterating with feedback from multiple people. But one thing that we did find really interesting was the exploratory visualizations, which are often start to cross the line into like the idea of mods, right? So sometimes, for example, in Civilization, users will create visualizations that can even be baked into the game as a tool for understanding, for example, how a specific decision would change the resource outputs of the civilization or something like that. And so in that case, what we actually see is that the person who is creating the exploratory visualization then releases it to the world. People are making their own specific custom visualizations based off of that kind of template, and then they're actually giving feedback to the person who created it and making suggestions for how they could change their template. But then as users, they're sort of like secondary visualizers themselves.
Cool. Joe has a comment. Have you looked at research on fan fiction? And mostly the comment is there seems to be a lot in common here.
I haven't looked at it very much, no. So I would love to, yeah, if you have resources, Joe, to share, that would be great. I definitely, yeah, I think we kind of just barely touched the surface of the, iceberg here of adjacent literature to read. So thanks.
Awesome. Thank you so much again for your presentation. I am going to pass over the virtual real mic to Lonnie. And if there's anyone that's won bingo, please go ahead and say it in the Discord channel. Thank you.
I guess you can take this mic and I can take this one. Sounds good. Cool. Thanks, everyone. So time for some concluding remarks on the Old Viz workshop. First of all, awards. I think this is a pretty big thing that we wanted to have this year. We kind of wanted to give a lot of awards to a lot of people that participated in this. So we're going to start the list here.
Our first award goes to Joe Wood for his paper, Beyond the Walled Garden, and the award is Most Meditative.
Yeah, go ahead. Round of applause. For the second paper, Ride Your Data by Vincent, Yvonne, Pierre, and Arno, we have the Most Immersive Award.
To Lonnie and Cody, we give the Most Dystopian Award for their work on dystopia.
For Ireland to Diffuse by Victor, Velichika, Ignacio, and Ethan, we give the Most Likely to Conquer the Potion Award.
To all the folks who were at that dog stool seminar, we give the most likely to walk around with a cup of coffee for Mephistos.
For the worst graph layout algorithm from Sarah, Matai, and Cody, we give the Worst Algorithm Award. Good luck with this one.
To Matt, Philippe, Palco, and Lev for their work on automatically generating paper names. We give them the Most Human-Centric, Insight-Based Crowdsourced Evaluative Exploration of the State of Art Award.
For Ready Play Viz by Jane and Michael, we give the Most Strategically Playful Award. And you think we'll be done, but we're not done yet. We have more awards to give. So first to two amazing reviewers that did a lot of reviews for Old Viz. James Scott Brown, we give him the Elizabeth Beck of Viz Award for his work finding actually duplication in the submission.
And to Michael Correll, we give the Oxford Dictionary Award for Most Loquacious Reviews.
There will be also a bingo award, so the winner will actually get an email or a DM from Daria very soon, or should get it now.
Assuming you've announced that you won bingo in the Discord.
Yeah, right. So yeah, you'll see about that very soon. Some reflections now before we conclude this. So first of all, this year we used open reviews, contrary to last year where we used PCS, to try and get pretty much like old Kai, anyone that wanted to review papers and to get anyone to see the reviews as well. I think it was a pretty cool thing. I'm pretty much always for transparency anyway, so I'm maybe biased there. But I think it was pretty nice. I don't know what you guys thought of it. I think this is something we could probably keep for the next years when we rotate over old VIS, but there's some reflections to be had there probably. Another reflection we want to have is whether we should have an old VIS 2023 or not, whether this is something we want to have every 2 years or every year. So this is something that I invite you all to think about. I mean, we've had a lot of submissions last year, a lot of submissions this year, so it seems like there's interest in this workshop, but if it's something maybe like the Believe workshop that we should have every 2 years instead of every year, that's also a possibility. And linked to that, I would like to invite you to help us organize the next old VIS. So we're trying to really rotate who is organizing it to try and get some fresh ideas, to try and get new people in. So feel free to reach out to us. If you go to the old VIS website, you will see there's a link to an email just to reach out to us. Then we will add you to a Slack where you can just say that you want to participate and help us organize the next old VIS. We're more than happy to rotate. We've been organizing it now for 2 years, so really happy to rotate out. And yeah, for the other people that don't want to organize, feel free to just send us your very weird papers next year. We'll be delighted to review them, even if we're not organizing. That's it. Thanks.
Thank you. We're also welcome to any comments or questions you have about the format of Alt Viz. If you want to pose a question, or if you want to pose a comment in the form of a question, you're welcome to do so via Slido, and I will read it. But it's also okay if you don't. Like all workshops, this one is one that is made by people, and so we want to made by and for people, and so we want to have it be something meaningful to you, and so we welcome your feedback. Also okay if you don't, we can just end.
Yeah, we can go for an early lunch, I guess. That never makes people unhappy, right?
Yes, it's true. Well, with that, thanks again.
Thanks, everyone.